How about now if we look through this code a little bit more and make sure you understand it? What does the say hi function do as given to you? It checks what's in that text box, packages it up into a JSON object, converts it to a string, sends it to the server. So say hi is actually the way we talk to the server. CB is how the server talks back to you. Response is the message the server has sent to you. And what this does is it parses that response into a JSON DOM and then does nothing with it. Actually, it pops up a message box to you, which is not what you want to do with it. But do you see that this is outgoing and this is incoming? That's important to recognize. Okay. And then there's this HTTP post function that I provided to you. Basically, you don't really need to look too hard at it, but long story short, it creates an XML HTTP request, which is a AJAX thing. This is how JavaScript communicates with a server. Okay, ask me some questions. What's unclear about how to do this assignment? Because there are a lot of parts here. I got to admit that. When you go out and work for some company, this project will look more like what that company is doing, probably, than anything else we've done this entire semester. So this is kind of your first real experience with the kind of stuff that real companies are making money doing right now. Chances are good the client might not be written in JavaScript. It might be written on an Android phone. So you might be doing both ends in Java. Although web browsers are still pretty important these days. A lot of companies want both a web front end and an Android front end. So I hope you'll understand you can do both of those. Also, whatever company you work with is not going to put you in charge of the whole darn architecture. Chances are they've got a great big project that works kind of like this. There's something in the cloud that runs on their back end. That's their server. There's a client that runs on the front end. And you're going to be in charge of some tiny little piece of it. So why am I making you understand the whole darn architecture? Yeah, you don't want to be the dude that works on the graphics of the front end because, you know, then you get artist pay, and artist pay sucks. You want architect pay, right? Architects are the guy that know how the whole thing works, and they're pointing, you do this, and you go work on that, and you tell me when you're done, and you do it. You know, that's the person you want to be. To do that, you got to have the big picture. So this is the tiniest, dumbest little program you'll ever see that is actually a cloud-based app, but I hope by having some experience with this, when you go out into the real world, they'll give you a little piece of project to work on, and you'll start to expand and say, yeah, I got this under control, but I should make it interface with that this way, and I should control that this way. And the boss will say, hey, this guy knows what he's talking about. Let's promote him to be in charge. And then you'll be in charge. So that's what I'm doing. Yes? Yeah, well, so the examples I'm giving you are not everything you can do. They're just enough to get you started. It is quite common to separate the HTML and the JavaScript. And I didn't even do that. I stuck my JavaScript in line. So it would be a very good idea to make a separate file with an extension .js and have it actually load source equals myscript.js. And then you can get rid of all this stuff. So that alone makes it cleaner because there's no HTML and JavaScript in the same file. Once you're in JavaScript, you're certainly going to break everything up into functions. And I've kind of showed one way of breaking it up into classes. A lot of people are using other JavaScript libraries and plugging them into theirs that kind of fake like they have classes by redefining the word class to basically mean all that stuff that I typed. You can do that if you want. Other than that, I'm not really providing a lot of guidelines on it. I'm just saying try to be organized. If nothing else, just separate your classes by having a whole bunch of white space and a big comment that says This is the view stuff. And then this is the, I don't know, whatever stuff. And that way you've at least got some organization in your code. And how you do it, I don't think is really super well defined. Okay. Use multiple files. Okay, cool. Yeah, you can include multiple files, and that's a great way to keep them separate. And yeah, so it's do whatever makes you feel organized, because that's if it's organized in your head, it doesn't matter what's happening on the file. It's your head that really is it's all about. Okay. I feel like I should give you some kind of an example. I just can't think of what the hard part is anymore. Oh, how about this? We talked about the server is going to have a Goomba X and a Mario X. What about the chat window? Yeah. So you could just have a window. So imagine on the server you have an array list, and in the array list is every message that has yet been sent. And then every time the client says, hey, what's new, the server could send to it the full list of all the messages that have ever been chatted. Could that work? Probably, because this assignment is so tiny, I bet you the grader would never notice. It'll probably work. Is that a good design? No, that's terrible, obviously. That would not scale. If you had 100 clients connecting to you, they all wanted to chat with each other, that's terrible. So how would you do it better? Here's what I'm thinking. What if every time a client connects to the server allocates a new object? So I'm imagining a class client. And on my server, I would have a whole array list of client objects. And in this client object, I might have an array list of strings, where those strings are messages that I have yet to send to this client. So now client 1 sends a message to the world. He says, yo guys, what's up? What the server will do is it'll go and drop that message into the list of messages for all the clients, for every single client except the one that sent it. And so that way, when all the other clients ping the server and say, hey, what's new? The server will respond, oh, you have one new message, here it is. And you have one new message, here it is. And then all those clients will get, so it's kind of like every client has their own inbox. Do you see how that's a way to do it? If when this client says hello, the word hello appears twice in his chat window, what happened? This client told the server a message, and then the client asked the server, hey, what's new? And the server said, oh, there's this new message. It says hello. And then your client thought it was brand new, even though it was the one you just sent. So you're going to have to do something to keep track of who sent which message and don't send it back to that person. And basically, simulated inbox is a decent way to do that. Okay? You could put in their inbox all the updates about where Goombas move or Marios move, or you could keep that as a separate model. Essentially, I don't want to give you too much direction on how to do that because I want you to have some experience architecting something. So for once, here's an assignment, and I'm not really telling you what structures to build. I'm just trying to give you some ideas, and you should be able to make these things talk to each other in a way that keeps track and doesn't get confused. Okay, if there are really no questions at all, I'm just going to let you go start working. Yeah. There's a protocol called Internet Protocol, which is called IP. And the Internet Protocol it works very much like the postal system. You put letters in the mail, you write an address on it, you send it off, and it just wanders through the world until it lands in the mailbox that you sent it to. There's something called an IP address. Have you ever heard of that? An IP address is this number that tells where on the internet the message is going to. And that's why I'm comparing the Internet Protocol to the postal system, is because every computer has an address. It's called an IP address. You send stuff over it. There's a problem with the internet protocol. If I send you a message and then I send you another message, it's quite possible message number 2 arrives before message number 1. And if you are getting strings out of order, then I might not be able to put them into a valid DOM, and my objects will get messed up, and that's very confusing. So somebody invented something called TCP, Transport something protocol. I can't even remember. The whole idea of TCP is it's kind of like an envelope in your envelope. And the outer envelope has a number on it that says what order the messages were sent in. And so basically you send messages with IP, Internet Protocol, and they arrive in your inbox, and then your butler takes all the mail and sorts it by opens all the outer letters, and then sorts them by the numbers written on the inner letters, and then hands them to you, and then you open them in order, and you get all the messages in the order they were sent. So TCP guarantees order. What do you send over TCP? Well, we usually use HTTP, which is a protocol for sending HTML. And inside of HTML, we have JavaScript. Do you see how there's a stack of protocols? And inside JavaScript, you're going to invent Mario Protocol. And as it turns out, Internet Protocol is written on top of hardware protocols like Ethernet, which are written on top of something else. So people that study networks love to talk about network stacks. And there's all these stacks of this is the outer protocol wrapping around an inner protocol, wrapping around an inner protocol. But basically, there's just numbers going over the wires. And all these numbers are doing is bounding these different components of the messages. And so when you've heard of TCP/IP, that is a reference to these two protocols which are being used together, and pretty much the whole 90% of the internet runs on TCP/IP. In fact, 89% of it probably runs on HTTP over TCP over IP. There are other protocols. One that's very popular is UDP that runs over IP, and that one's used a lot with games. It doesn't come with as much overhead. It's a little faster. Gamers like UDP. But we're not going to talk about that. Take a networking class if you want to learn all about it. Essentially, this is called a protocol stack, and a protocol stack means that there's a lot of protocols that are used to make the whole darn internet work. Okay, any other questions? Well, thanks for coming. I will release you 4 minutes early to go get started on this assignment. Feel free to use the forum and ask questions, and see you next time.